The focus of this video will be on the inverses of trigonometric functions. So far what we've been doing in class is you have been evaluating a trigonometric function. So you found the sine by looking at the y value, the cosine by looking at the x value, and tangent by evaluating y over x of a given theta. So we looked at theta in degrees, we looked at theta in radians. Now what we're going to do is with an inverse, I give you the side length or the value, and then we're going to find theta in degrees and in radians. The easiest way that I can do this is just to show you examples, but first I just want to talk about notation really quick. So once again, remember theta is our values in degrees or radians. Oops, let me scooch that over. And then we call that alpha, the A. Alpha is going to be the, I'm going to say value, but that just means the side lengths if we were looking at a triangle on the unit circle. So what we're used to doing is we're saying like sine of theta and we would find this value. For example, what is sine of, let's say, 90 degrees? That would just be 1 because that's the y value of 90 degrees. Now what we're going to do is sine inverse of alpha to find theta. So if I would have said, what is sine inverse of 1? You could have wrote 90 degrees, or that's equivalent to pi over 2. So it's basically the opposite of what we've been doing in class so far. Let's start with example 1. Example 1 says that we're going to be finding the trigonometric inverses, which is what this notation represents right here. Part A asks for us to find the values between 0 and 2 pi, so everything that's on our unit circle, for which sine of theta is equal to root 2 over 2. You could either pause the video and draw your unit circle really quick or pull yours. Okay, so I went ahead and I pulled out my this is called a trig tracker. I'll eventually give you a copy of this, but the question said, find the values between 0 and 2 pi, so from our unit circle, for which sine of theta is equal to root 2 over 2. Well, sine, we know, is the y value. So we're just going to take it one quadrant at a time and see when is the y value a positive root 2 over 2. So we're going to start here at 0, okay, from 0 to 90 in quadrant 1. When is the y value positive root 2 over 2? That would be right here. So one of the answers is pi over 4 or 45 degrees. We want to put both down. So theta equals pi over 4 or 45 degrees. Okay, let's look at quadrant 2. I'm just going to move the camera. So in quadrant 2, the y value is positive root 2 over 2. So we're going to write 3 pi over 4 or 135. 3 pi over 4 or 135 degrees. If I look at quadrant 3, here's a y value of root 2 over 2, but this time it's negative. So that doesn't work. And then quadrant 4, once again, here's a y value of root 2 over 2, but it's negative, so that also doesn't work. Which means we have two solutions, and I wrote both of those in radians and degrees. Let's try it again. So for part B, it says values between 0 and 2 pi, so that just means we're looking at the unit circle, for which tangent theta is equal to 1. So tangent is y over x, and we want to know when is equal to 1. So something is equal to 1 if it's that something over itself, meaning you should instantly think about 45-degree angles because their coordinates are root 2 over 2, root 2 over 2. So something divided by itself. This would not give me 1 if I would do y over x, and this would not give me 1 if it was y over x. So I'm going to start here. I want a positive 1. So a positive root 2 over 2 divided by a positive root 2 over 2 would give me a positive 1. So one of the solutions is pi over 4 and 45. Let's look at quadrant 2. Again, I want to look at the angle with a 45-degree reference angle, which is right here at 3 pi over 4, or 135. Now, it's y over x, so positive root 2 over 2 divided by a negative root 2 over 2. So positive or a negative would give me a negative 1 for the tangent, and that does not equal a positive 1, so this does not work. In quadrant 3, we have root 2 over 2, root 2 over 2, and both of them are negative. So 2 negatives does give me a positive, meaning 5 pi over 4, or 225, is a solution. And the last quadrant we have to check is right here, quadrant 4. Negative and positive means I would have a negative tangent, so that also does not work. Okay. Now, I'm just going to scooch it over. We'll do the left side first, and then we'll go back to this other side. Now we're just going to answer each question. So I want to know, what is the cosine inverse of 1/2? And the way we answer this is basically the way we were thinking about it in example 1. What value for theta will give me a x value of 1/2? Okay, so this is equaling theta. I want to know what theta is. And again, this is an x value. So we're just going to look at the unit circle. I'm going to start with quadrant 1. X is positive 1/2 right here. So 60 pi over 3. Scooch this over. Now I know, if I think about the signs, that the x values are positive in the first quadrant and the fourth quadrant. So if I want my cosine to be a positive 1/2, I know I can't use anything in quadrants 2 or 3. So I'm just going to look at quadrant 4 now and ask myself, when is the x value a positive 1/2, which would be right here at 300 degrees, or 5 pi over 3. Okay, next, I want to know, when is cosine inverse of -1? So what theta value would give me an x value of -1/2? Well, I know x's are positive in quadrants 1 and 4, so I'm just going to skip over here to quadrants 2 and 3. And the only time x is a -1 would be right here at 180 degrees, or pi. So that's exactly what I'm going to put. 180 degrees, which is equivalent to pi. So hopefully we're starting to pick up on it. Let's do another one. When is, why don't we do, I'll do B and D with you now. So part B, when is sine, so that's a y value, a negative root 2 over 2? So think about the signs in your coordinates, or excuse me, your quadrants. Your y values will be negative in quadrants 4 and 3. So that's where we want to be looking right now. And if I want the y value to be a negative root 2 over 2, that should make you instantly think about a 45-degree reference angle. So that would be here at 315, 7 pi over 4. So I'm just going to scooch this over. 315 or 7 pi over 4. And then I also had a y value of negative root 2 over 2 right here at 225 or 5 pi over 4. Tangent is a little bit different because tangent is y over x. So I need to be looking at the coordinates and thinking, okay, when in the unit circle will I get 0? Well, obviously, if I'm going to get 0, one of the coordinates has to be 0. So I'm going to start here at 0 degrees. Y over x, so 0 over 1 would give me 0. And I'm going to put 0, 360 or 0, 2 pi. Now I'm going to look here because there's a 0 in this coordinate as well. However, when I do y over x, 1 over 0 is not 0. That would be undefined. So that one doesn't work. Over here, pi and 180. 0 over negative 1 would give me 0, so I'm going to put that as a solution. That's 180 or pi. And then last one to check. This also has 0 in its coordinates. However, y over x, negative 1 over 0, that is undefined, so that would not work. I'd like for you to pause the video and attempt E, F, G, and H. When you're ready, hit play. We're going to check E and G first. E was pretty straightforward. You had to look at the y values and see when you would get a positive root 3 over 2. So if you look at your unit circle, a positive root 3 over 2 is here, which is 60 pi over 3. That's listed as one of my solutions. And then also here at 122 pi over 3. Tangent inverse is a little bit harder just because it is y over x. So you have to be thinking about actually dividing the values. And we wanted to get a negative 1. So whenever tangent is a positive 1 or a negative 1, you should instantly think of things that have 45-degree reference angles, because those coordinates have root 2 over 2 and root 2 over 2, which when you divide something by itself, it is 1. Because it was negative, you had to use the quadrants that had different signs. So that would be quadrant 2 and quadrant 4. So that's how you should have written your answers. Okay. F was again pretty straightforward. Cosine is the x value, so you had to see when was x a positive root 3 over 2. Because x is positive, you should have known to look here and here, so the first and fourth quadrants, and those were your solutions right there. And now H. This is probably the hardest one just because tangent is y over x and it wasn't something nice like 1 or 0, it was root 3. So I knew that because it's not 0, it wouldn't be this. Because it's not undefined, it wouldn't be this. Because it's not 1, it's not going to be this one. So it's either going to be pi over 6 or pi over 3. So the first thing that I did was I just tried solving for y over x. You can see that here. The first one I tried is I looked at the pi over 6, or 30 degrees. So y divided by x is 1/2 divided by root 3 over 2, which you can see here. I did keep, change, flip, and ended up with 1 over the square root of 3, which I had to rationalize, and it didn't give me just a root 3. So that didn't work. Then I tried pi over 3, or 60 degrees, y over x, keep, change, flip. I did get root 3. So I went back and I used the things that had same signs because it was positive. So same signs meant it's in the first quadrant, which is right here, and then the second quadrant.